Many critical infrastructures, such as communication networks and transportation, rely on semiconductor technology. For example, each smartphone has a processor as its brain and several image sensors as its cameras. All are made from semiconductor technology. But what exactly are semiconductors, and why can't we use something else? Metals conduct electricity well, so they have good or high electrical conductivity. Insulators have poor or low electrical conductivity. Sitting between metals and insulators in terms of electrical conductivity are the semiconductors. Having intermediate electrical conductivity doesn't seem all that useful at first glance. However, semiconductor engineers can precisely control the electrical conductivity of semiconductors. By intentionally adding impurities, which are other elements, we can change the electrical conductivity by a great deal. The same semiconductor can go from being a poor electrical conductor to a good electrical conductor. We now have large variation of electrical conductivity that we can control precisely. This combination is the key reason why semiconductor materials are the perfect candidate for the many electronic devices we come to rely on. A given semiconductor material behaves differently as temperature varies. Therefore, semiconductor device manufacturers must make sure their electronic devices perform well over a specific range of temperatures. This is important since applications such as automotives can demand high operating temperatures. Different semiconductors have different electrical and optical properties, so there is flexibility in choosing the right semiconductors in device designs. Silicon is the most commonly used semiconductor. It is used for manufacturing integrated circuits, or ICs, which are essential for computing and smartphones, as well as virtually all forms of electronic controls. Silicon is also the material used to produce photovoltaic solar cells, converting solar energy into electrical energy. Silicon is formed by just silicon atoms. Some semiconductor materials are made out of two or more types of atoms, and these are compound semiconductors. Compound semiconductors are particularly useful for making electronic devices that emit light, such as LEDs and lasers, or those that absorb infrared light, such as infrared optical sensors. Electrical signals move faster in certain compound semiconductors than in silicon. So those compound semiconductors are used for making devices operating at very high speeds. There are others with excellent properties, even at high temperatures, making them ideal for applications such as power management of electric vehicles. Inside a semiconductor device, there are no moving parts, unlike in mechanical devices. So semiconductor devices are much more reliable than their mechanical counterparts. Decades of semiconductor research and manufacturing innovations have also provided astonishing improvements in device performance and cost reduction. As a result, more and more applications in our daily lives are relying on semiconductors. And those that already do continue to demand more advanced semiconductor technology. It has already enabled important developments in areas such as renewable energy generation, artificial intelligence, and automotives. Their importance is only going to increase in the future. So learn more about them with us in our later videos.